Alright, so in this video, we're gonna go over area of a sector. So previously, we did problems related to arc length. Now we're gonna do the area. So let's revisit. What is a sector? A sector is like the pie-shaped part of a circle. Something like this, right? And O is your origin, your center of the circle. This is gonna be your R. These are your radii. And this is the angle theta in radians made in between them. And yeah, that is about it, right? So this is a sector, and we are looking for this area, the area that I have shaded in yellow. So now if I know R and if I know theta, is it possible to find the area in yellow? That is the question. All right, so let's try to relate. I know that a full circle, which is 2 pi radians, corresponds to pi r square, right? Pi r square is the area of a circle. 2 pi radians is that the angle there, right? So what is 1 radian going to correspond to? Well, 1 radian is going to be pi r squared divided by 2 pi, right? So I divide by 2 pi here, and I divide by 2 pi here. And my pi's are going to cancel out. So I know that 1 radian, this area, so if this is 1 radian, right? If theta is 1 radian, then the yellow area is going to be half r squared. But usually theta is not 1 radian, right? So what happens in the general case? If we just have theta radians, then your area is going to be half theta r squared. And that is the formula we are going to use. So if your angle is theta radians for this sector right here, your area is given by half theta r squared. So that is the formula you want to remember, half theta r squared. All right, and with that in mind, we can start doing some questions. So part A, you are given the radius, you're given the angles. The area of the sector is half theta is pi by 6, r squared is 12 centimeter squared, right? And if you simplify 12 centimeter squared, you're going to get 144. All right, so 6 times 2 here in the denominator, you are going to get 12. So overall, you are going to get 12 pi centimeter squared. That is going to be your solution, 12 pi centimeter squared for A. For B, it's the same, right? Your area is half times theta is 2 pi over 5 times r squared is going to be 10 squared. 10 squared is just 100, right? 100. 5 times 2 in the denominator will give me 10. And 100 divided by 10 times 2 pi. So if you simplify this expression, you get 20 pi centimeter squared, the units of area. And we are done with part B. And C and D is the same. What is the area? Area is half times theta, which is 2 pi over 9. Remember, whatever we have discussed in this chapter, always use radians. 2 pi over 9, and then r is 4.5 squared. And if you plug this into your calculator, right? Or if you don't, so 9 times 2 in the denominator, I get 18. 4.5 squared divided by 18. So if you simplify that fraction, you should get 9 by 8. So 4.5 squared is 20.25. And 20.25 is 81 by 4. And if you simplify everything, you get 9 by 8 pi centimeter squared. Sorry, no. Okay, let's try again. So 4.5 centimeters, right? So your area is half. Theta is 2 pi over 9. 4.5, you can write it as 9 by 2 squared. And your answer is going to be centimeter squared, right? If your radius is in centimeter, your area is going to be in centimeter squared. All right. So you have half times 2 pi over 9 times 9 over 2 squared is just going to be 81 over 4. And if you simplify this, 9, this will give you, this, so 2 and 2 will cancel out. And 81 by 9 is just going to be 9 pi over 4 centimeters squared. So that is going to be your solution for C. So now I'm not going to do D. I'll leave that for your own, but it's very straightforward. Just use the formula half theta r squared. So pretty much question 2 is the same. The area is just half times theta is 1.5 times radius is 34 squared. And if you plug this into your calculator, you get 867 centimeters squared. For B, it's the same. Area is just half times, what is theta? Is 0.9 in radians times 2.6. So if you're given in degrees, you have to convert it, right? 2.6 squared. So your answer is 0.5 times 0.9 times 2.6 squared. And you get 3.042 centimeters squared. And that is how you do question 2. Question 3. They ask you for the angle, you're given the area. So that is just a rearrangement question, right? Area is half theta r squared. So if you have to isolate theta, which is the angle you're looking for, if you multiply by 2 on both sides, you get 2a is equal to theta r squared, and therefore theta is going to be 2a divided by r squared, right? You need theta, so you have to use this expression. So what is 2a here? 2 times area is 9, divided by r is 4 squared, right? 4 squared. So your answer should be in radians. 9 2 is 18 over 16. 4 squared is 16. So you get 1.125 radians. And you do the same here. Your theta is just going to be 2a over r squared. So 2 times area is 27. And r is 6. So 6 squared is 36. So 54 over 36, that gives you 1.5 radians. So that is how you do question 3. Alright, so I hope I can erase everything, because these are very, very straightforward, direct questions, right? Alright. So we are done with 1, 2, 3, and we are going to do 4. Sorry about that. So let's draw question 4. AOB is a sector. So O, I like to keep it as my center. So I'm going to draw it like this. AOB is my sector. Our radius with center O with radius is 8 centimeters. So I'll call this 8 centimeters. I'll call this 8 centimeters, right? Both of them are the radii. The length of the arc AB is this part is 10 centimeters. So find AOB, which is this angle theta, in radians. Well, remember, from the last topic, theta, so L is r theta, right? That is what we learned. So theta is just L over r. L is 10 centimeters, r is 8 centimeters. And if you use your calculator, 10 over 8, that gives you 1.25 radians. That is going to be your solution, 1.25 radians. All right, and what is the area of the sector? Well, area of the sector is just half times theta times r squared. So I can just substitute half times theta, I just calculated to be 1.25 radians, and r squared is just 8 squared. So if you substitute everything, you should get 10 centimeters squared. That is going to be the area of your sector. Sorry, 8 squared is 64. So it's going to be 40 centimeters squared. 0.5 times 1.25 times 8 squared is 64, so you get 40. Sorry, I did 8 squared is equal to 16 on my calculator. I'm so sorry. Alright, it's 4. Alright, so question 5 says that the diagram shows a sector POQ of a circle, center O, with radius 4 centimeters. So this is also going to be 4 centimeters, right? Because this is our sector. The line PX and QX are tangents to the circle at P and Q respectively. So that means that this angle is 90 degree and this angle is 90 degree. Why? Because if this is a circle, if this is the tangent line and this is the radius, then the angle between them must be 90 degrees. And it's the same here. This is the radius, this is the tangent line. So the angle between them must be 90 degrees. So that's a result that you can remember. So find angle POQ in radians. All right. So we are given one extra information, and that is this length of this arc, which is PQ, is 7 centimeters. All right. So this angle, which we will call theta, we know that theta is just L divided by R, because L is R theta. And now you just do 7 centimeters divided by 4 centimeters, and that gives you 1.75 radians. That should be your answer, right? So theta is 1.75 radians. All right, that was pretty straightforward. Now let me erase this. So now I will draw a straight line connecting O and X. And remember, this was a straight angle, right angle triangle, right? Because this figure is symmetrical, right? If you fold by this line, this part is gonna connect here, right? It's a symmetrical figure. So this middle line actually divides the angle exactly into two. So this is gonna be 1.75, the angle that we found, and it's gonna be the half of it, right? Because the total was 1.75, so it's just gonna be half. And 1.75 divided by 2, that gives me 0.875. So that gives me 0.875. All right, so that is the angle. And let me go close my door for a while. I'm so sorry. So 0.875. And now I can use some basic trigonometry, because I know that tan of my angle, which is 0.875. So let me label my triangle. Right angle is here. Opposite is going to be my hypotenuse. This is adjacent. Opposite to the right angle is my hypotenuse. My adjacent is 4 centimeters. Adjacent to the angle. Opposite to the angle is my, what I call normally my opposite side, right? So if I use tan, then that is going to be my opposite, which is px, what we are looking for, and my adjacent is just 4 centimeters. So using this equation, px is just 4 times tan of 0.875, and that gives me, so tan of 0.875 radians, remember your calculator must be in radians mode, times 4, that gives me 4.78968 ... and I can round this, I can to 3 significant figures. This would be 4.79 centimeters. All right, so we are done with A and B. So find the area of the shaded region. So let me erase this again. I hope that is okay. So what is the area of the shaded region? Well, it's the area of the whole figure minus the area minus the yellow area, right? Alright, so it's going to be the whole area minus the yellow area. Can we calculate the yellow area? Yes, we can. So the yellow area is just half theta r squared. From the formula we know, because that's just the area of a sector. So half theta is 1.75 radians. We calculated in part A, times r squared is just going to be 16. And if you solve this, you get 14 centimeters squared. So the yellow part is 14 centimeters squared. Now let's find the area of this big kite-like figure, right? So the big kite-like figure is this one. Sorry, so let me just erase the yellow area for now. So the kite-like figure that I'm talking about is the whole thing, right? And if I minus the area of the sector, I get the area of the shaded part. So how do I calculate this? Well, remember, I divided it into 2 triangles. So I just double the area of one triangle. So the area of the kite, I'm going to call it the kite, is just the area 2 times the area of one triangle. And one triangle has the area half base times height. This is 90 degrees. This is 4 centimeters. So I know how to calculate the area of the triangle, right? Because I know what px is. I already calculated px. And I'm going to use the whole value. I'm going to use 4.789686517 that I got in my calculator. I'm going to use this when I put it. So 2 and 2 cancel out. So area of the kite is just bh, base times height. So what is the base? The base is px that we calculated. So it's going to be the ugly expression times the height is just 4 centimeters. And if you do that, you get 19.15874607 centimeters squared. And finally, the area of the shaded part is going to be total, your area of the kite, the whole purple area, minus the yellow portion that we previously highlighted, right? So it's going to be 19.158 dot 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 minus 14. And if you do that, you get to 3 significant figures, you get 5.16 centimeters squared. So that is your final answer, 5.16 centimeter squared. All right. So we are done with question 5. I hope the explanation was clear, right? Okay, so 1.75, 4.79, and 5.16 centimeters squared. But when you plug into your when you are using the value, please use this one. Please use the yellow one. The whole long value, you round off at the end. So it's always helpful to save the long value as well. All right, so we are done with question 5. So I hope I can erase this so that I can move on to question 6. All right. Question 6. The diagram shows a sector PQR, all right? So this is OP, op. The op is also going to be 8 centimeters. And, okay, the angle is given. OR and QR are perpendicular. OR, yeah, okay, so this angle is 90. And OPQ is a straight line. All right. So find the exact area of the shaded region. So let's see. We have a right angle triangle with an angle, right? So we can obviously find QR. What is going to be QR? Well, tan of the angle, tan pi by 3 is opposite. Opposite to the angle is the length QR divided by the adjacent, which is 8 centimeters. So QR is just going to be 8 times tan pi by 3 centimeters. So if you plug this into your calculator, so tan pi by 3 is actually a special value. Tan pi by 3 is root 3 centimeters. So your final answer is going to be 8 root 3 centimeters. So just remember, for now, tan pi by 3 is root 3, square root of 3. You can plug into your calculator and keep the long value as well. That is also okay. So if you plug it into your calculator, if you do 8 times tan pi by 3, then you get 13.856 something something. But I prefer to keep... So I prefer to write it as 8 root 3 for now. 8 root 3 centimeters. All right, so now the area of the shaded region is going to be area of the triangle minus the area of the sector, if you think about it, right? So you find the area of the whole triangle and you take away the area of this sector, this pizza-like shape. All right, so what is the area of the whole triangle? Well, that's just half base times height. And what is the area of the sector? Well, it's just half theta r squared. So half, what is the base of the triangle? Well, it's QR that we just found. It's 8 root 3. 8 root 3 times what is the height? Is 8. So that is the area of the triangle minus half. What is the angle? The angle was pi by 3. What is the radius? It's going to be 8 squared. So if you calculate this, so if you plug everything into your calculator, you get 21.9153. So if you simplify, you just plug this expression into your calculator, you should get this value. And this, when you round off to 3 significant figures, is just 21.9 centimeters squared. So that is going to be your final solution. 21.9 centimeters squared. All right, so I did not realize that the textbook uses exact values. So we're just going to simplify. We're not going to simplify. Like, we're not going to give the calculator value. We're going to just normally simplify. So all right, so if you simplify, 8 divided by 2 here gives you 4 times 8 root 3. So this side of the expression simplifies to 32 square root of 3. Minus, let's simplify this side. 8 squared is 64 divided by 2. That is 32 pi over 3. So that is your solution. Centimeter squared. All right. So we are done with question 6. So, they say exact area. So you just want to find this expression. All right. So this was 6 was fairly straightforward. 5 had a lot of parts. Question 7. So the diagram shows a sector AOB of a circle center O with radius 5 centimeters. So OB is also going to be 5 centimeters. The line AP and BP are tangents to the circle at A and B. So this is 90 degrees and this is 90 degrees because it's tangent to the circle. And find the length, exact length of AP. All right. So if I connect this should divide pi by 3 into exactly half. So pi by 3 divided by 2 is going to give you pi by 6. So this angle is pi by 6. And we can use some basic trigonometry, right? So I know that sine is tan pi by 6. Tan pi by 6 is opposite. Tan is opposite, which is AP, over adjacent, which is 5. So therefore, AP is going to be 5 tan pi over 6. And tan pi over 6, if you know the exact value, is 1 over root 3. So it's going to be 5 over root 3 centimeters squared. Sorry, centimeters. And another way to write 5 over root 3 is you rationalize it. So you multiply and you divide by root 3. And in the denominator, you just get 3. So you can write it as 5 root 3 by 3 centimeters. That is also okay. That is the exact length. Now find the exact area, right? So I'm going to erase this, if that is okay. All right. So this was 5 root 3 by 3 centimeters, right? So I'm just going to draw it here. AP, 5 root 3 by 3 centimeters. All right. Find the exact area of the shaded region. Well, the exact area is going to be the same process again, right? This is a right angle triangle because this was the tangent line to the circle. So it forms a 90-degree angle with the radius down here. This is the radius. This was a tangent line. So this angle must be 90 degrees. So we can find the area of this right angle triangle and multiply it by 2 so that we get area of the whole kite. So area of the kite is 2 times the area of one triangle, and area of a triangle is just half base times height in this case. So you just have base times height. The base is 5 centimeters. The height we just calculated is just going to be AP, right? So it's going to be 5 root 3 by 3 centimeters. And that is going to give you 25 root 3 by 3 centimeters squared. All right. And now, what is the area of one sector? The area of this sector, the one in yellow, is something we can calculate because we know the angle, we know the radius. So the area of the sector is going to be half r squared, half r squared theta, or half theta r squared. So half r is 5 squared, which is 25, and theta is pi over 3. So that is going to be 25 pi over 6 centimeters squared. All right. So finally, the exact area that we are looking for is going to be the area of the kite, the big thing, minus the area of the sector. And that is just going to be 25 root 3 over 3 minus 25 pi over 6 centimeters squared. And you can actually write this as a common denominator, right? So you can factor out 25 over 6. And in the first bracket, you are going to get 2 root 3 minus pi centimeter squared. So you can write, so these are equivalent expressions. Writing like this and this is the same. For the second answer, I just factored out a 25/6 from both sides. All right. So if you think about it, this 2 and 6, they will cancel out and give you 3 in the denominator, right? So no changes done. So that is the solution for B. And we are done with question 7. All right. So question 8. So I hope if the... All right. So question 8. To solve question 8, we need to find the area of the shaded region. So here's the idea. We are going to find the area of this triangle first. Okay, I hope it's clear that it's a triangle. Oh, let me draw the bottom line more carefully. Okay, it doesn't work. Let me try again. Okay, something like that. We're going to find the area of this triangle, and we are going to subtract out the area of these 3 sectors. So that is what we are going to do. But to do so, we need the angle of the triangle, right? We need the angles. So now, let's call this angle alpha. We're going to call this angle beta. And this angle is going to be gamma. And alpha plus beta plus gamma, because they are angles of a triangle, have to add to 180. 180 is pi radians. We're going to work with radians, right? All right. So now, how do we find alpha? Well, we know 2 sides of the triangle. We know 2 sides. So we know the base, we know this side. So we know this side, we know this side. We want to find this angle, and we know the opposite side. So that is the cosine rule. The cosine rule, as we have discussed previously, is going to look something like this. So I'm going to redraw our upper triangle. But this is A, the angle opposite to A, side A is angle A. If this is B, the angle opposite to side B is capital B. If the angle is C, the side opposite to it is going to be C, right? Something like this. And the cosine rule tells us that C squared, small c squared, is A squared plus B squared minus 2AB cosine of C. And now let's redraw the triangle, right? Because this side is 4 plus 2. B is 4 plus 2. If you can see here. Because this is 4, this is 2. So 4 plus 2. That gives me 6. C is just 6 plus 4, right? It's going to be 6 plus 4. All right. And 6 plus 4 is going to be 10. And A is going to be 6 plus 2, right? 2 and then 6. All right, 6 plus 2 gives me 8. So now let's find, first of all, we are going to find B. We are going to find angle capital. So we already have given these names. This is alpha, this is beta, this is gamma. All right, so now if I have to write the cosine rule in terms of the angle alpha, it's going to look something like this. The side opposite to alpha, which is 6, right? It's going to be 6 squared is equal to, you take your 2 sides, 8 squared plus 10 squared minus 2 times 8 times 10 cosine of alpha. That is how the formula is going to look like. So let me just quickly draw your triangle for you again, and I'll write the 3 versions of the cosine rule. So this is capital A, side A, capital B, side B, capital C, side C. So C squared is going to be A squared plus B squared minus 2AB cosine C, right? A squared is C squared plus B squared minus 2CB cosine, and what is the angle opposite to A? It's cosine A, right? And it's the same. B squared, which is this side squared, is just A squared plus C squared minus 2AC cosine of B. So these are the 3 versions of the cosine rule that you may want to remember. All right. So now using one of these forms. So I'll leave you to figure out how we can use these formulas to use this. And I know the cosine rule, we have never mentioned it before. It's not in the syllabus, but it's helpful to know because a lot of geometry problems where you don't have right angle triangles, you're gonna need this. So now we can figure this out. So 36, right, is 64 plus 100 minus 160 cosine of alpha. And if you solve this, you're going to get 36 minus 164 divided by negative 160 to be your cosine alpha. So we are simplifying this expression, right, to solve for cosine alpha. And you get the expression cosine alpha is going to be 0.8. And alpha is just cosine inverse of 0.8. Alright, so that is the value of alpha. And now we are going to look for beta as well. So if we want to find beta, we are going to use 8 squared. The side opposite squared is equal to the other two sides, right? 10 squared plus 6 squared minus 2 times 10 times 6. So again, I'll leave you to figure out how we get this expression. But it's using these three formulae. So you figure out which one is more appropriate, and when you plug the values in, you're going to get things as follows. And then cosine of beta. Alright, and now if you solve this expression, you are going to get 64 is equal to 136 minus 120 cosine of beta. So I know I'm doing the calculation a little fast, but I hope you can catch up. And if you solve for beta here, you're going to get cosine beta is 0.6. And beta is going to be cosine inverse of 0.6. Alright, so we have our alpha, we have our beta. Now we need to find our gamma. And gamma, we remember this relationship. So gamma is just going to be pi minus alpha plus beta. It's going to be pi minus cosine inverse of 0.8 minus cosine inverse of 0.6. Alright, and now if you do this in your calculator, you get 1.570796327 radians. Alright, so that is going to be gamma. So we know alpha in radians, beta in radians, and gamma in radians. So we know our three angles. And if we know our three angles, we can now find the area of the triangle and the three sectors. So let's find the area of the triangle. So your area of the triangle is half base times height. What is your base? Well, your base is just 10, right? So half times 10 times height. So it's going to be 8. So let's drop this line here. This is going to be h, right? Sine of alpha is going to be h divided by the hypotenuse. So this forms a right angle. The hypotenuse is 8. So h is just 8 sine alpha. And we are going to use this. So if you substitute h is equal to 8 sine alpha here, you get half times 10 is 5. 5 times 8 is 40. Sine alpha is just cosine inverse of 0.8. Alright, and if you solve this, you are going to get 24 centimeters squared. That is the area of the triangle. So if you plug your values into your calculator, you get 24 centimeters squared. Now let's find area of sector 1. So what is sector 1? I'm going to call, this part to be sector 1. So my sector 1, if I erase the other parts, is going to be the yellow part, right? So my area of sector 1, the formula for area of a sector, as we have discussed, is half times theta times r squared. The angle for sector 1 is alpha, if you remember. The angle is alpha times, what is the radius? Well, it's 6 squared. The radius of this circle is 6. Alright, so if you simplify, this is 36 by 2 is 18 alpha. And if you do this in your calculator, 18 times alpha, which is cos inverse of 0.8. So 18 cos inverse of 0.8 radians, you get 11.58301 996. Something like this. Now let's find the area of the sector 2. So that is going to be half theta r squared. So we'll call this region to be sector 2. All right. So it's going to be half. The radius is going to be 4 if you think about it closely. Okay, sorry. It was something like this. Okay, something like this. Okay, sorry, my drawing. Okay, so this area is sector 2, right? The radius is going to be 4, and the angle here we called it beta. All right, so it's going to be half beta, and it was 4 squared. So 16 divided by 2 is 8 beta. Beta is just 8 cosine inverse of 0.6, right? And you get 8 times cosine inverse of 0.6 gives you 7.41 something. 8361744. That is what you get. Now let's find area of sector 3. And that is going to be half. Your final angle is gamma r squared. And remember, your final radius is going to be 2 squared because the small circle, this part, has a radius of 2. All right. So it's going to be half. Gamma was 1.570796,327, right? This is gamma. And 2 squared is 4. So 4 divided by 2, you're just going to get 2. All right. And if you do that calculation, you are going to get 3.14159265 something something. So this is just pi, actually. All right. So area of sector 3 is just going to be pi. And now that we have that, this expression is actually pi by 2. So gamma is actually this, you actually figure out, is a right angle triangle. All right. So this is pi. And now once we have this down, we can add the 3 areas together. So what is the area of the shaded part going to be? Well, it's going to be, if this is the shaded part, it's going to be the area of the triangle minus this sector minus this sector minus this sector, right? So what we are going to do is we are going to do area of triangle, which is 24, minus area of sector 1, so 11.58, you you plug everything, minus sector 2 is 7.4183, minus sector 3 is just pi, right? And if you plug everything into your calculator, 24 minus 11.58, 301,996 minus 7.4183 61744 minus pi. If you do everything, you are going to get the expression 1.8570 ... And if you round this to 3 significant figures, it's going to be 1.86 centimeters squared. Rounded off to 3 significant figures. All right, so that is going to be the solution. 1.86 centimeters squared. I know it took us a lot of time, but I hope it was clear how we got this answer. 1.86 centimeters squared. All right. So now I hope I can erase everything. So in the beginning, it wasn't clear, it wasn't obvious to me that this is a right angle triangle. So you can actually use basic trig as well. This can be your alpha, this can be your beta, this is your 90 degrees. So beta is just 90 minus alpha actually. So this is just pi by 2 minus alpha. So that makes things easier. But it wasn't obvious to me that this is going to be 90 degrees. So that is why I did the long way. All right. So let's do question 9. So I hope I can erase everything. Okay. So now question 9. The diagram shows a semicircle with center O and radius 8. All right, so this side is 8 and this bottom side is also 8. So this is 8 and this is 8. All right. What more? FH is the arc of a circle. So this is the arc of a circle, center E. Okay, that is something we'll keep in mind. Find the area of triangle EOF. So we are going to find the area of this triangle. All right. So to find the area of this triangle, this is going to be the height of the triangle, right? All right, so what is this angle going to be? Well, it's going to be pi minus 2. This whole thing is 180 minus 2 radians, right? Pi radians minus 2 radians. All right, so now I know that, hey, if I take the sine, this is a right angle triangle, sine of pi minus 2 is going to be opposite, which is my height, divided by my hypotenuse, which is my 8. All right, so h is equal to 8 sine pi minus 2. All right, radians. All right, so the area of my triangle is half base times height, half base is 8, height we just found it out is 8 sine pi minus 2. And if you plug everything into your calculator, you are going to get 29.09751 centimeter squared. So to 3 significant figures, your answer is going to be 29.1 centimeter squared. That is the solution to A. That is the area of the triangle EOF. All right, what is the area of the sector FOG? So that is just half theta r squared, right? Area of a sector is half theta r squared. So which is the sector FOG? So let me erase everything. So FOG is this sector. So we already found this angle. This angle was pi minus 2. So we just substituted into the formula. Half theta was pi minus 2. The radius of the sector is 8 squared. All right, and if you substitute this into your calculator, you are going to get 36.5309 ... And if you simplify your to 3 significant figures, you are going to get this expression. All right. Part C. Area of sector FEH. All right, so let me erase this. What is the sector FEH? It is going to be this part, right? FEH is this sector. And remember, we are given something. FH, which is this, is the arc of a circle. All right, we are given that this is the arc of a circle. That is important to know. So it's the circle centered at E. So this is also a center of a circle, and this is the outline of a circle. So we want to find this sector's area. And how do we do that? Well, it's going to be the area of the triangle So let's find, so one way to do it is we can find EF by using the cosine rule. We can find EF, and that is going to be the radius, right? So I'll say that EF squared, and remember, I already gave you the expression for the cosine rule, so I hope you wrote that down. But it's going to be my 2 side squared, 8 squared plus 8 squared, minus 2, 8 times 8, cosine of this angle, right? The opposite angle, which is 2 radians. And if you solve this, if you plug this into your calculator, sorry, EF, right? EF. All right, you get EF squared. The expression for EF squared that you are going to get is $181.2667951, and that gives you EF to be 13.46 something, right? 13.46353576. centimeters. So that is the radius of your new circle. And now you can find your area of the sector. So we know EF. What is this angle? Well, now we need to find this angle. And to find the angle, we are going to use... Now remember, this is 8 and this is 8. So this is an isosceles triangle. So if this is alpha, this is also going to be alpha, right? So 2 radians plus 2 alpha, the sum of the 3 angles must be pi radians. So 2 alpha must be equal to pi minus 2. Alpha is pi minus 2 divided by 2. That is the angle. And using everything, the area of the sector is going to be half. The angle is pi minus 2 divided by 2. And your radius squared, which is, your radius is EF. So EF squared, we are going to use 181.2667951, right? And if you substitute this into your calculator, you are going to get 51.7332141 centimeters squared, which is just going to be 51.7 centimeters squared to 3 significant figures. All right. And the final part, so we are done with A, B, and C. What is the area of the shaded region? So the area of the shaded region is the area of this sector. This the area of... So, all right. So we know the area of this sector, right? We already calculate the area of this sector. All right. So we know the area of this sector, and we know the area of the triangle. So we also know the area of this triangle. All right. So if we do that, if we do the area of the big sector, so we know the area of the big sector. The big sector, which we found, was FEH, right? This FEH, this part, this sector. If we do that, sector FEH minus the area of the triangle, we are going to get the area of the yellow portion. So let's just compute that. So 51, so area of the sector FEH is this expression. So 51.7332141 minus area of the triangle, which is 29. I am going to use full expressions, right? 751 dot 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 dot, and that gives me area of yellow. And area of the yellow part you are going to get is 22.63569275 if you put it in your calculator, centimeters squared. All right. So that is the area of the yellow part. So now let me erase this. We know the area of this sector. We know the area of this sector, FOG. We know the area of the sector FOG because we already calculated for part B. So if we do area of sector FOG minus the yellow area in the previous part. So what was the yellow area? The yellow area was this one, right? So if we do that, then we get the area of the shaded part. So area of sector FOG comes from part B, which is this expression, right? 36.5309. So just use the whole expression that you must have saved in your calculator. So it's useful to write everything down. And area of the yellow part is 22.63569275 dot 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 dot. And that gives you the area of the shaded part, which is going to be 13.895 dot 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 dot. And to 3 significant figures, you're going to get 13.9 centimeters squared. So that is your solution to part D. The area of the shaded region is 13.9 centimeters squared. All right. Question 10. The diagram shows a sector EOG. So EOG is a sector of a circle, center O with radius R. Alright. The line GF is tangent to the circle at G. So that means that this is a 90-degree angle. That is all that it means. Because this is the radius. If this is tangent, then they must form a 90-degree angle. And E is the midpoint of OF. Alright, so we know that this is also the radius. And because E is the midpoint, this must also be R. So in total, OF must be R plus R, which is 2R. So OF is this part. And using the Pythagorean theorem, we can find GF, right? So GF squared, which is this part, plus this part, right? GF squared plus R squared is going to be OF squared. So GF is just 2R squared plus R squared is OF, sorry, we don't know GF squared, plus R squared, and we know OF is 2R squared. So GF squared is going to be 3R squared if you simplify everything, and you are going to get the value of your GF to be square root of 3 times R. Alright, so GF, this bottom part, is square root of 3 times R. So let me just quickly erase this so that I can write square root of 3R. And yeah, everything else we have it down. So what is the perimeter of the shaded region? So we need this angle, right? What is that angle going to be? We can use, because this is a right angle triangle, we can call that angle alpha. And we can take the tan of alpha, which is going to be opposite, over what is the hypotenuse? Well, this is the hypotenuse, right? 2R. Sorry, no, it's going to be root 3R, opposite over adjacent, which is R. So that is tan alpha. And R cancel out, so you get tan alpha is square root of 3. And alpha, if you take the tan inverse, you are going to get pi over, so root 3 is a special value, so it's actually pi over 3 radians. Because tan 60 degrees is root 3, and 60 degrees is pi over 3 radians. Alright, so we know this angle is pi over 3. So now we can find the length, L here. That length L is just r theta. What is r? Well, it's just r, and theta is just pi over 3. So it's going to be pi r over 3. So that is L. And now we can find the perimeter. The perimeter is just going to be the bottom part, GF, which is root 3r, plus the curved part L, which we just calculated to be pi r over 3, plus EF, this part, right? So this part plus this part plus this part. We found L, we know this, so this part is just R, plus R. Alright, so now if we do this, we can factor out the R. We get root 3 plus pi over 3 plus 1. And if we factor out a 3 from this expression, we are going to get this. And that is what the question asks us to show. So 3 plus pi plus 3 root 3 over r over 3. So if you factor out a 3 from this expression, you get the solution to part A. Alright, for part B, we need to find the area of the triangle, the big triangle, and we need to take away the area of the sector, right? That gives us the area of the shaded region. So what is the area of the triangle? Well, it's half. The base is root 3 by root 3 times r. And what is the height? Well, it's just r, right? Minus, what is the area of the sector? It's half alpha, which is the angle, times r squared. So if you simplify this, you get root 3 by 2r squared minus half. The angle was pi over 3 that we calculated here, and the radius is just r squared. Alright, so now you can factor out the r squared from this expression, and you get root 3 by 2 minus pi by 6. Alright, and if you factor out a 6 from the denominator, you get the expression 3 root 3 minus pi. Alright, and if you actually multiply things inside, you will get this. If you multiply 1 over 6 inside, you get the above expression. So this is exactly what the question asks us to show. And we're done with part B.